All right, guys, we are extending our conversation. Limit definition of a derivative. So the other day we did this. This is going to be h as h approaches zero. Sorry, guys. Let me back up here a little bit. As h approaches zero, and that's going to be of f of x plus h minus. We said f of a, right? That's right. This is going to be an a, and this is going to be as h approaches zero. So that was our definition to find the slope of a tangent line. So we're going to take that definition here and we're going to move it into the definition of a derivative. All right. So let's just talk about some different things like this. So we're going to mean what the meaning of differentiable. We're going to talk about different ways of denoting a derivative and all sorts of information. It's kind of crazy. And then graphing derivative from data and all this crazy stuff. So just remember the derivative gives the value of a slope of the tangent line to the curve. And we're calculating it using the secant line, is what we talked about today in class. So here's my definition of a derivative. I want you to guys look at this, and I want you to notice how similar it is to our slope of a tangent line using that formula I gave you. We used f of a plus h, right? That's what we used the other day, but now we're using f of x and f of x. So it's really the same thing, but here's our notation that's a little different right here. This f prime, we call it f prime, means the derivative. That is the signal. That is the derivative of f. So f prime, we call that f prime. It's a little asterisk right there. Not asterisk, little quotation mark, apostrophe, whatever you want to call it. That means that it is the derivative of f. Okay? All right, so now let's look at this. So a differentiable. So when we find the derivative, we are differentiating it. I can't spell it very good. Differentiate. So that means to find the derivative. So so the idea is this. We have to follow the domain issues. So if the domain of f prime has to make sure that it matches the domain of f. Okay? So in other words, f has to be continuous. F has to be continuous. All right? It has to be continuous. Oops, I don't know. Continuous. F has to be continuous. If it's not continuous, then it's not differentiable. Okay? That's what all this mumbo jumbo says. Okay? So it has to be continuous. You can't have breaks in the line. So that means we may have to set domain limits on it or domain boundaries. Okay? So domain boundaries. All right. So let's look at this a little bit. So let's look at this bad boy right here. This is kind of the one we did in class together. Uh, and that's why I chose x squared. So differentiate. That means find the derivative. Find the derivative. Now the derivative is, remember, the slope of the tangent line. Oops. Tangent line. Okay? It's the slope of the tangent line. Let me get rid of that. Let me clean that one up. Right. Oh, I just had it. Dang it. All right. Slope of the tangent line. Okay, those two mean the same thing. Slope of the tangent line is the derivative. So if we are given f, which is x squared, we are going to use this limit formula right here, where it's f prime of x, the derivative of x. Derivative with respect to x is the limit as h approaches 0 of this function right here, or this slope. Remember, this is the change in y over the change in x of the secant line, that triangle I drew up there. So what we do is we take this function here and we substitute x plus h in, and that's what it is. X plus h is now x, so it's x plus h squared, minus the function itself, which is x squared. So we do some algebra, we get it all squared away, and we get x squared plus 2xh plus h squared, and that's what they mean by expanded x plus 2. All right, so now what do we got? We've got this other piece, and if you look here, this x squared and this x squared are going to cancel, so I'm left with this piece here. Well, here they make the assumption that you know how to factor it, so they factored out an h and they factored out an h. So that's where this came from. So what happens to the h's? They cancel, and so now I have a part where I can substitute it in. I substitute in h, and so my f prime of x is equal to 2x. That is the slope of the tangent at any point on f of x equals x squared. Okay? Any point. All right. So there's a couple of other ways you can look at it. Uh, again, really, this is the exact same formula. Look, f prime, f of x minus f of a over the change. There's just all sorts of ways you're going to see this. There's just different ways. That's why they call this the alternate form. There's all sorts of ways that you're going to see this thing. Just remember, when you see this f prime in the limit, this is the limit definition. There's another one that I believe looks okay as the change in x approaches 0, and it's f of x plus the change in x minus f of x all over the change in x. And if you look, this is like h, and that's like e. There's all, like I said, there's a ton of ways that this thing gets written. Just remember, it's that basic idea. So now let's get into some vocab pieces. So here's some y prime. That's this piece right here. Okay. Y prime, it's quick, it's easy, but it only names y because there could be dt, there could be t, it could be t prime. So it doesn't name the independent variable. Okay, dy over dx. So really want to see this one. This is like the change in y over the change in x. The difference of y over the difference of x. So it's the derivative of y with respect to x. That's what they're saying there. It names both the variables and uses d for the derivative. Okay? All right. So now, this one here, this could be anything, any function. So it could be d of t, d of m. So this is d of f with respect to x. Okay? So it's the derivative of the function with respect to x. Notice how they're always with respect to x, which is always the x-axis. Okay, so your x-axis will always go on the bottom here. Okay, and so we're just looking at some different pieces here, and like this one here, it's the emphasis on you're differentiating f of x is basically what you're saying is the derivative of f at x. So all of these mean that we're going to denote finding the derivative of a function. Okay, all sorts of different ways to write that thing. All right, so we talked about this a little bit. Okay, so we can get a good idea of what the graph of the function looks like by estimating the slopes at various points. So in other words, like if, and we'll do this in class, I'm going to say, you know what, we're going to do this in class. We're going to talk about that in class. Okay. All right. And we'll just talk about this slide in class. It's a lot easier, and I can do it on the board. Okay, same thing here. Graphing the derivative from data points. We'll kind of deal with that. So, and so the idea of this is it depends. This is kind of like for piecewise functions. Okay, and so it depends on what we're looking at. So this is piecewise. So when we're coming in from the left, they just signify that A is a different value on the left of it, and B is a different value on the right of it. So like let's say we have a piece here, and then we've got this one here, and we've got this one down here. Well, we're not going to call this one here the same value. So let's just say it's approaching, find the limit of this one on the left, and that's going to be our A. We're going to find it at point A right here. Let's just call that point A. And this one is point B. So you have to come in, and I did it backwards. It honestly doesn't matter what you do, but according to this, we're saying coming in from the left, right? That one's coming in from the left. So this would be point B. And this one's coming from the right, so that would be point A. So if it's coming from the right, you would use this one, which is still the same formula, guys. And if it was coming from the left, you would use this one. Okay? You don't have to be exact with your A and B. Just understand that even one-sided derivatives will still be able to use the formula. You just got to use it. You got to use the correct function according to like a piecewise graph, let's say. All right. So today, it's kind of a quick little video. Today you're working on worksheet 9. Follow the steps on worksheet 9. The steps are going to have you walk your way through each piece. So it's going to say find f of x plus h. And that's going to be like one step. Okay? And then it's going to say like find f of x plus h minus f of x. And it's going to gradually work you through step by step to where you end up with f of x plus h minus f of x all over h, and it's the limit as h approaches 0. Okay, so they're just walking you through the steps. Again, worksheet wise, this is the last time we have to worry about it for the limit definition. And I'm just going to drive home the fact one more time that it doesn't matter the curve. It could be something like that. Number one, it has to be continuous. Number two, what are we finding? We are finding the slope of this green line based on this triangle right here. Okay? So if we really look at this, this is my change in x. Here's my change in y. And that's what this here is, that part right there. And this here is that part right there. So does this change in x approach 0? What happens to y? That's kind of the idea, guys. So our whole slope idea, starting from rise over run has turned into the difference in y over the difference in x, or better known as f prime or y prime, or the derivative. All right, guys, we will see you soon.